You are an hour into a coding session. The logic is finally clicking together. And right as you ask for the core function, Claude locks you out. You have hit your usage limit. Claude's newest updates are powerful, but that capability comes at a cost. They consume your usage limits at a significantly accelerated rate compared to older versions. We are going to address that. By adding 3 specific commands to your workflow, you can optimize Claude Code and delay these limit lockouts. To follow along, you just need an active account and your Claude Code environment open with /commands enabled. Getting control over your token burn protects your attention. It keeps you in a flow state where the work actually gets done. The first step is configuring Claude to automatically delegate tasks based on model efficiency, rather than relying on a one-size-fits-all approach. To set this up, type /model opus plan into your interface. This setup assigns the heavy opus model to the role of high-level planner, processing complex architectural blueprints. Then, Opus passes those plans down to Sonnet 4.6. Sonnet acts as the fast, efficient executor, handling the actual line-by-line code generation. A common error is leaving Opus set as the default model for everything, including basic, repetitive debugging tasks. Forcing a heavy, computationally expensive model to scan for simple syntax errors creates massive token waste. Dividing the labor matches the AI's capability to the task's complexity, stretching your usage budget significantly further. Now we need to address a hidden cause of rapid token drain that occurs during extended chat sessions. This chart tracks token burn over a long conversation. Notice how the line climbs. That happens because Claude has forced to reread your entire compounding chat history from top to bottom on every single new message. The immediate solution to stop this compounding problem is the /compact command. Running this command forces the AI to condense your previous history into a tight summary. It discards irrelevant code blocks and dead ends while retaining your core instructions. Here is the interface. The endless scroll of your chat history on the left is replaced by a clean, single summarized block on the right. Proactive context compression stops compounding token waste. It keeps the AI's memory sharp and ensures your token burn stays strictly linear. The final point of failure happens when the AI generates incorrect code, forcing you to ask for multiple revisions. When you initiate a complex task, add the word ultrathink to the end of your prompt. This parameter forces Claude to calculate a structured, step-by-step plan before it is allowed to write a single line of actual code. Contrast this with the standard method, where the AI guesses the solution, writes it out, realizes it failed, and rewrites via trial and error. Getting stuck in that trial and error loop is one of the fastest ways to hit a usage limit. You will know you've successfully bypassed this when a distinct thought process or outline block appears on your screen prior to the code generating. Enforcing pre-computation trades a tiny upfront token cost for massive backend savings by ensuring the code is right on the first generation. Implementing these 3 specific commands transforms a standard Claude setup into a workspace designed for efficiency. The result is a significantly longer window for deep coding sessions before those usage limits become a factor. Screenshot these commands or write them down to build immediate muscle memory for your next session. Check the comment section below to find a link to a full advanced Claude course along with a curated list of additional AI tools. Taking intentional control over how your AI processes information keeps your focus on the problem you're solving rather than the resource limits of the tool.